Hey guys, welcome back to my YouTube channel. So in this lecture, we are going to continue our discussion on the charge density, electrical field and voltage. So last class we have discussed about the electrical field and those things. So in this voltage curve, that what we got here is that, so in this one, the equation 4, we are substituting this equation. So 5 in 4. So when we substitute the 5 in 4, so we will be getting some relationship there. So when reordering that thing, we will be able to get this one. So this is square root. So for linear junction, we will be getting the square root. For non-uniform doping, there will be 1 by 3 for non-uniform doping. For uniform doping, we getting the square root, right? So similar to that, if you try to do in a non-uniform doping, we will be getting 1 by 3. So that is not needed in our syllabus of analysis. So we will skip those things. So now let's see the instead of Pn, now see N and P junction. So you guys may think there won't be any change because of this, but there will be a lot of changes because of this. So I have already given some indication. So if the polarity or the charge carriers are reversed, then the electrical field direction will change. Based on this, the potential and analysis will also be changing. So here it will trace the boundary. Here it is positive charge, so it will go up. So it will go up and it will trace like this, and then it will come down. So like this way it will behave. So then if we draw the electrical equation, then it will trace the boundary here. It will go up here, then slightly downwards, and then it will trace like this. Electrical field will be like this way. So similarly, voltage will also be in the opposite direction to that. So first it will be like this, and then it will trace like this. So it will go like this. So it will be positive charge, here it will be negative charge. So this is charge density. Here it is xp, and here it is minus xn. So everything will be changed. So charge density. Okay, so this is a of x and this is v of x. This net height is v naught. Okay, this is v naught. Okay, so this is what the quite difference. So similar to this is completely for the linear junction or uniform junction, not linear junction, that is uniformly doped junction. So the next thing of analysis is completely linear junction or non-uniform junction. So here it is a linear junction or non-uniform junction. The same, the finding of electrical field, potential, everything we can do for this non-uniform doping also, but this is not needed in many of the syllabuses. It's remote, so that is completely not needed, so you guys can skip it. But for your understanding, I will be letting you know what will be the difference will be there. So one of the major difference is that the dou v, the rho v is there, right? So rho v, the values will be quite different. So there we can see some constant value, but here the rho v will be q alpha x. So this will be the value. The alpha is the impurity gradient. Alpha is the impurity gradient. So this rho v will be used to find the electrical field and voltage. So every value will be changing. So that we no need to worry about this. You guys can skip this understanding. So just you guys can know in non-uniform doping, the values will change. Like last class I stated, right? So W now will be depend on cubic root. So the value will be 12 epsilon V naught divided by Q alpha whole power 1 by 3. There we have seen something, right? So with the square root we have seen. So this one is modified there. So 2 epsilon V naught by Q alpha into 1 by 3. So this is the only one change that we can see in the junction of diodes. So if you guys need to do, you guys can even analyze the electrical field voltage and charge carrier density, those things also there. But that is not needed, because and once we guys able to grasp the concept in the linear junction, non-uniform junction, then that itself will be fine. So no need to worry about all the things. So I'm sure that you guys able to now understand what is mean by PN junction and what are the impact that is made in when we combine both the junctions. So next class we'll be starting with the diode current. So the discussion will be diode current. So today let me revise all the things that we have seen so far, so that you guys can get a new idea on all the new topics that we are going to see. So let me revise all the thing from the PN junction. So this is the PN junction that we have started. So P and N, these are the charge carrier profile that we have noted. So in the P type, the majority charge carrier, P type, minority charge carrier. So when we combine both the region, the depletion region will be getting formed, and from there we can clearly see that there will be some here the majority charge carrier will be formed to minority charge carrier. So this change will happen. Here minority charge carrier will go through this depletion region and become majority charge carrier. So this difference will happen in the PN junction. So at equilibrium, we know that everything is constant. So there will be no current flow or anything will be happen. So nothing will happen. So that thing we know. So this is the thing that, but what we can see is that there will be diffusion of P and diffusion of N charges to different things, from higher concentration to lower concentration to higher concentration. But because of this, everything will be cancelled out and there will be no charge carrier movement. So net carrier will be 0. So only there will be supply or there will be current movement only when there is an external supply produced. Then we have gone through a depletion approximation for charge density. So this approximation model only we have used so far in our diagrammatic representation for P and NP junctions. So here we see how to draw the electrical field and voltage, and then these value, electrical field, voltage value, everything, how to find all these values we have already gone through very detailedly. So when we do forward biasing, forward bias means P is connected to P and N is connected to negative. So then how the current will flow is that the depletion region is need some kind of P in the P side depletion region need holes and N side depletion region need electrons. So when P is connected to P, then holes will be injected from this side and that will be migrating to depletion region and will remove the potential barrier of depletion region to 0. And then because of the external supply, more holes will be diffusing to N region, and the excess majority charge carrier from here will recombine with the majority charge carrier in the N type. So that recombination will be the our net application, maybe an LED or even a current flow or any kind of application. So similarly here more number of electrons will be reducing the depletion region here, and the majority charge carrier of electrons will go to here and recombine with the holes in P region. So this is how the current will flow. The net current will flow from the positive to negative terminal. In the reverse bias, what will happen? The many number of electrons will come and even recombine with the holes present in the P region. So this will further increase the depletion region. So no more current will flow in the forward bias. So only some negligible leakage current will flow from here to here. So that will be in some microamps to nanoamps based upon the semiconductor. Then the energy band diagram we have seen. So without connecting both the junction, everything will be separate, and this difference will be Q V naught. Okay. So then we combine it. Then the Fermi level will be combined. But based upon this, the EV and EC will be get adjusted. Here E and EC are same level. Here Fermi level is distance. When combined, Fermi level will be combined, but E and EC will be adjusted. So this barrier potential difference will be reduced if it is forward bias. The red color I am indicating is reduced thing because of forward potential. But blue color I am indicating is reverse bias. Because of the reverse bias, the potential is further increasing, so that it will make the electrons and holes to jump from its state to another state, so that there will be no current flow. So this is how the Q V naught can be found out. So the V naught can be found out from the difference of EFN to that of EFI, then EFI to EFP. So we know this equation from the semiconductor device basics. So let's see, if we combine both things, then we will get this formula. 1, 2, 3, 3 different varieties of formulas we will getting. And then we have found two different types of junction. One is uniform junction, another one is non-uniform junction. So in the uniform junction, we have seen the charge carrier profile doping will be uniform throughout the semiconductor. So from that, we are finding out the E and V. So E can be found out from the Poisson's equation. With this one, using this condition, we will be able to get the E in both N and P region. So this is what the P region E, and this is what the P region N, N region E. Then E naught can be also be found out when x is equal to 0. And from this equation, if we negative integrate the E of x, then we can get V of x. So then V of x can also be found out in both the region, that x is equal to minus xp in the P region and x is equal to x and h is also in the N region. So if we know in the N region, we will be getting some xp, xn, both are related in this term. So already know this inequality equation. So if we substitute xn and xp in the equation 4, like this equation, the xn and xp in the equation 4, then we can able to get the depletion region with formula. So the V naught here will be changing based on reverse bias and forward bias. So if V naught is forward bias, then that voltage will be subtracted. Then the depletion region width will decrease. V naught is reverse bias, then the V0 net voltage will increase, so that the depletion region will also increase. So I hope this is understood for you guys. So here we have drawn a diagram of NP, the reversed potential, so that electrical field maximum will be top, electrical field will be positive value, and the voltage value is drawn in this side. So similar to that, for non-uniform junction, there will be small change in the rho v. There rho v is constant, but here rho v will be depending on the x and another one alpha, the impurity gradient constant. So based on that, if we substitute E and V, then the depletion with formula will vary. So that instead of 1 by square root, it will be on the cubical root. So this is what one quiet difference that will be there. So from next class, we'll be starting with the diode current. Once the diode current is done, then we'll be going to some special devices like solar cell and the other light devices. So those things we'll be discussing up in this lecture. So I hope up to which you guys able to get some concept there. So I'm leaving this to you guys. So if you guys have any doubt, please ping in the comment section. I will for sure clear it. Thank you. Stay tuned, guys.